Then tajuk tadi adalah Introduction to Control System. Okay, itu adalah kita punya chapter 1. Okay, Introduction to Control System. Okay, now kita tengok our chapter 2, Block Diagram and Transfer Function. Okay. Hopefully tak tertidur ya. Hopefully tak tertidur. Takut penatkan puasa ni. Okay. So guys, everybody with me? Mana nanti? Okay, right.
Yes,
Still with me.
madam.
Good. Okay, now we start sharing our second topic from control system. Okay. Now we will be covered on the block diagram and transfer function. Okay. Let's we see the expected. Okay. Once we complete this chapter 2. Okay, the first one. Okay, should be student be able to determine the transfer function of the control system from its block diagram. Okay, now here we have two methods to define the transfer function. Okay, the first method we have use the block diagram reduction method. This is one technique to define the transfer function. Okay, this one we want to define this. Okay, this is we want to define the transfer function. The second technique we use block diagram reduction method. The second technique, okay, or the second method we use signal flow graph. Okay, this is the second one to define the transfer function, right? So meaning the signal flow graph is, let's say, you will be given the block diagram first. Okay, you will given the block diagram and then you have to draw block diagram into signal flow graph. Okay, once you have your signal flow graph, you use this method or you use this rule. Okay, you use Mason's rule to define the transfer function. Okay, but the first one we see the first method, block diagram reduction method. Okay. Okay, this one just now we sharing about summing junction. Okay, this is a summing junction. Okay, and then summing junction, and then the element of the block diagram. Summing junction, peak off point. What is a peak off point? Peak off point is here. Okay, this is a peak off point. Okay, R, meaning R is represent your input. Okay, as R is represent your input, and then C is output. Okay, and C is your output. Okay, we have here. Okay, we have three topologies that we can use to solve a complex block diagram into a single block. Okay, so meaning we have three form, meaning from the complex block diagram you can see cascade form. Okay, you can see cascade form, parallel form, and feedback form. Okay, so meaning, let's say I give you a complex block diagram. Okay, so first step, you have to define from the complex block diagram where is the cascade form, where is the parallel form, and where is the feedback form.
Salin. Ini namanya itu.
Okay, you have to define three forms first: cascade, parallel, and feedback. So how the parallel looks like and how the three form look like. Cascade, how the cascade looks like. Okay, this is a cascade looks like, and then how to we reduce when we apply the reduction technique. Okay, the first one, cascade. Okay, this is a cascade connection. Okay, meaning cascade connection or series connection. Okay, meaning you have a block here. Okay, we have a block G1 and we have a block G2, and then how we want to apply this technique. Okay, we want to apply this technique instead of we have two block. This is the two block. Okay, we reduce, we apply the reduce technique and we get one block here. Okay, how we want to apply this reduction technique. Let's say the first one, cascade. Okay, let's say we have G1, G2, and then we can combine these two blocks and then we multiply G1 multiply with G2. We get this one. This is a combination, or this is the reduction technique when from the complex block diagram, you can see a lot of block there, and then you have to find out which one is a cascade, and then you can simplify the cascade. Let's say you have G1, G2, you have two block, you want to make it a one block. Okay, so G1 multiply with G2, so you can get this one. Okay, you can get this. Okay, this is the result after we combine two block. Okay, so meaning G1 multiply with G2 if we have the block in cascade. Okay, the second one is a parallel. Okay, what's meaning parallel connection? Okay, you have two block. We have G1, we have G2, and then this is the signal. Okay, and then this is also the signal. Okay, the signal is come from peak-off point. Okay, one signal is a G1, another one is a G2. Okay, the both signal is goes to summing point. Okay, and then how we want to reduce one block, make it one. So we get this one, G1 plus G2. Okay, class, you can follow me. Okay, this is how we want to combining block in parallel. Okay. Okay, right. So how about another one, feedback. How we want to reduce feedback form. Okay, let's say feedback G, oh sorry, G is our forward parts. Okay, we call G is our forward parts. This one, G is our forward. Okay, forward parts. And then H is our feedback element, or G is our forward. Okay, forward element. G is our forward. I say it's a forward gain. Okay, and H is our feedback gain. Okay, so G is your forward gain and the H is your feedback gain. Okay, this is consider we call feedback form. Okay, feedback form, and then how to eliminating a feedback form. So from here we get this one. We simplify, instead of two block we have a G and H. We combine, we get this one. Okay, and then how this is considered formula how to eliminating a feedback loop. Okay, let's say G, the formula from this, let's say we have a G, okay, and then the output, the feedback element with label with H, okay, and then R is your input and output we label with C. Okay, and from here, let's say this is a minus. Okay, how to eliminating this feedback loop? Okay, the formula is, okay, we want to define the transfer function. Let's say R input, C output. So the transfer function ratio is a C over R. Output over input is a ratio of the transfer function. Okay, transfer function is a C over R. Output over input. Okay, output over input equal to what? Okay, what is, so we we determine this transfer function from this system G. Let's say this is a minus, the formula is 1 plus, if this minus 1 plus G, the forward gain plus with the feedback gain. Okay, let's say plus here. Okay, so you change, this is make it minus. Okay, class, can you follow me?
Yes.
Okay, good.
Yeah.
Okay, this is considered similar with this one. How about the second feedback? This is also the feedback, but the feedback element equal to 1. Okay, because this is, we call this without gain, is it? Okay, this is without gain or without block. We call unity feedback. We call unity feedback. Meaning unity feedback is a, oh, sorry. If unity feedback is H equal to 1. Okay, this is called unity feedback or H equal to 1. Okay, similar with this one. Okay, H equal to 1, right? Okay, and then how to simplify or how to eliminating this feedback, and then we can get this example, this formula, because H equal to, H equal to 1, right? So we can get G over 1 plus or minus G. 1 plus or minus G, you have to refer with this one. If they give you plus, meaning you get minus. If minus, you can get plus. You have to change the what, the sign. Okay, like this one just now. Okay, you have to follow the sign, whether minus or plus. But this is the formula. Okay, this is the formula how to eliminating feedback loop. Okay, let's say, you see this first example, what you can see from here. What you can see from here, this one, the first example for reduce the block diagram, we want to define the transfer function. Okay, you want, okay, so the first one, okay, let's say I give you this block diagram. Okay, so first you have to define 3 type of connection: cascade, parallel, and feedback. Okay, so now from here, what you can see from this complex block diagram? What you can see, G1 and G2 is a cascade, is it? So you can combine the G1 and G1 and G2, like G1 and G4. Okay, this one. Okay.
Yes.
So you can combine. Okay, this is the cascade. Okay, this is a cascade connection. Okay. How about G2 and G3? What type of connection? G2 and
Parallel.
G3. Okay, this is a parallel. Okay. And then you can solve cascade and parallel first. Okay, we solve cascade and parallel. Step 1. So you can solve step 1, combine or cascade, so you can get G1 multiply with G4. Okay, we finish this one. And then just now is parallel. Parallel G2, and you can see the sign here, plus, plus. Meaning we get plus here. This is like a mathematics operation, okay? If they give plus, you make it plus. Let's say I give you minus, okay, meaning how to solve it? How to solve it for parallel connection? If I give you minus, meaning if you simplify, you can get G2 minus G3. Okay, I give you minus. So we just follow the, if minus, you can put minus. Okay, if plus, make it plus here. Okay, class?
Yes, madam.
Okay, now
Yes.
we finish step 1 and step 2. You redraw back into the system. Okay, we draw back so you can get ni ya, sekejap you can get this one. Okay, from here is this is from the step 1. Okay, cascade, and this is from the alamak. I have to show you both slide because this is a interconnect. Okay, now we finished step 1. We combine G1 and G4, and then step 2 we combine the parallel. Okay, G2 and G3, and then you can get step 3. Okay, step 3 meaning you have G1 here. This is your step 3. Okay, once you cascade, you got this one. And then this is from here. Okay, now after we cascade, you can solve this one. So meaning you can get this one, right? Betul tak? You akan dapat ni kan? Okay, this one here. Is it correct?
Yes.
Okay, everybody can see after cascade, when we redraw, you can get this one. The inside the green circle. Okay, class. Can you follow?
Yes.
Yes,
Okay.
madam.
Okay, inside the green circle, okay, after we proceed step 1, okay, we combine G1 and G4, so we can get this one, right? Okay, after that, we redraw back, so you can get this one. Okay, when you draw back, you can get this. Okay, so what types connection this one? What type of connection this one? It's a feedback, right? Is it correct feedback? Is it feedback or parallel? For this one, step 3. For this one, what type of
Feedback.
the connection? Feedback, right? Okay. So meaning feedback, we apply the reduction technique so we can get this one, G1, G4. So we can get this one. Because this is a minus plus, so the answer is a minus, right? Okay. So meaning this one is a G1, G4. Okay. 1 minus G1, G4 multiply with the H1. So you can get this. Okay. This is the answer after you apply the feedback loops. Okay. Or feedback transformation. Okay. So from there, you redraw back. So we can get here, here. We draw back our system. Okay. So we can get to put back here. And then G1, G4 is from where? This one. This is from step 2, right? So, okay, from step 2, we can get this one. Okay, we draw back. Okay, oops, sorry. Okay, so this one from step 3. Okay, this is from step 3. Okay, and then here is from step 2. Okay, and then you get this one. Okay, this is after we, okay, this is from step 3. This is from step 2. Okay, and then you draw back. So you can get like this. Okay, class? You can follow me?
Yes.
Okay, very good. Okay, so meaning after this, how about, okay, let's say I label back. Okay, now after we proceed step 1, step 2, step 3, we redraw back our question, and then you will get, okay, you get this one. Okay, from here, I label for you. I will relabel. Okay, I will relabel. This is A, and this is B, and this is C. Okay, so what's connection you can define for this? How about A and B? Is it A and B, cascade, parallel, or feedback? Okay.
Cascade.
Okay, A and B is a cascade, right?
Yes.
Okay.
Yes.
So we multiply A and B, so we can get this one. Okay, and this is a C. Okay, and then how we want to solve for A, B, and C? What connection?
Feedback.
Yes, very
Feedback.
good. Okay, very good. So you have to solve A and B, C using the feedback rules. Okay. So class, let's finish. Find out the transfer function. Okay. Hopefully you do your own. Find out what is the transfer function. Let's I put the question mark there. Okay. Can you make it as your homework? C over R, meaning C is your output. Okay. C is your output and R is your input. Now we want to define the transfer function for this system. Okay, this is a transfer function. Alamak. Okay, this is, we want to define the transfer function from this block diagram using reduction method. Okay, so what is the transfer function? Okay, so let's try after this class, you find out what is the transfer function for example 1. Okay, how about example 2? Sorok dulu jawapan. Saya nak bagi tengok. Okay, so how about our example 2? What type connection you can see from this example?
G2, G3 cascade.
Okay, G2 and G3 cascade. Okay, this one is a cascade.
Then feedback with H1. Then
Okay,
feedback with
good.
H2. Feedback with
Okay,
H3. And then cascade
okay,
on.
okay, right. Okay, first cascade, lepas tu next you feedback with H1, feedback with H2, feedback with H3. Is it, Mio?
Yes. Then cascade with G1.
Okay, and last kali cascade with G1. Okay, so is it possible if the first one is cascade? Okay, let's say I make it this one cascade. Okay, we can get G2, G3, right? Okay, cascade. Okay, is it possible if instead of you feedback 3 times, is it? First let's say this I make it A. Okay, A, C, oh sorry, A, C, A, B, C, and D. Okay, just now Mio say A feedback with B. Next let's say we can get X. Is it? X feedback with B. Is it? We can get Y. And last one is what? Y is a feedback dengan apa Mio? Feedback dengan D kan? Okay, we can get Z. Okay, that's another one method. Is it anybody can see another method instead of feedback 3 times? Who can see? Instead of feedback, another method we want to solve. For H1, H2, H3, who can see another method instead of feedback? Who can?
Settle the feedback first.
Sorry, Mia?
Settle the feedback first. H1, H2 and H3.
Tak boleh. Tak boleh settlekan dulu
Parallel
sebab
ketiga tu.
kita, apa dia? Okay, H1, H2, H3. Can I solve this one using parallel? Is it? You can solve H1, H2, H3. You can parallel 3 block. H1, H2, H3. Okay? We can solve the second method. You can also solve the second method. See this example. How I solve H1, H2, H3 using parallel connection. Okay, first we do in series. Okay, this is our step 1. We cascade this one. Okay, instead of we do 3 times of feedback, we can parallel H1, H2, H3. So we can get this one. Okay, class? Step number 2. Okay, H1 and H2 and H3 are in parallel. So we can solve this one, meaning like this. Okay, H1. Okay, let's say like this. But before that, you have to see this one, the sign. Okay, meanings minus. Allahu Akbar. Okay, so okay, minus H1 and from there plus H2 and then H3 minus, right? Minus H3, is it? Class? Okay, can follow?
Yes.
Okay,
Yes.
from here we take minus outside, so meaning this one is H1, this one is H2, and this one is a minus H3. Can I rewrite like this?
Yes, ma'am.
Okay, so from there I get this one. Okay, minus, this minus I bring here. Okay, I bring here minus. Okay, and then inside this bracket I put here. Okay, you can still can follow?
Yes.
Okay, very good. Okay, now we complete step 1, step 2 and step 3. So from here, how you want to solve it? Next step. So meaning, let's say madam label, this is A and this is B and this is C. Okay, first step, how you want the step 1 done, step 2 done. Now we go to step 3. How to solve A, B and C?
Feedback.
Which one feedback? A and B.
A and B.
Okay, A and B we feedback first. Okay, so meanings mana dia? Dia dah bagi transfer function tadi. Okay, so meaning you have to solve A and B first. Okay, so meaning you have to solve this one first. Okay, you have to solve this one first. You feedback, right? So you feedback first A and B, meaning this is the answer for feedback A and B. Okay, you get this one, feedback A and B. You can get inside the blue box, and after that you cascade with, this is C. Okay, this is a C. Okay, A and B inside the blue box, and after that, once you complete the feedback A and B, the last step you multiply or you cascade with C. Okay, the last you can get the transfer function. Okay, this is the overall transfer function. Okay, this is the transfer function. CS, C output over input. So we can get this one. Okay, class, any question so far?
No.
Everybody can follow, still can follow. Baca chat jap. Siapa cakap parallel H1, H2, H3? Ah, very good. Fahana. Okay, Fahana kata H1, H2 parallel. Yes, okay. Okay, we finish example 2 now. Allah Akbar. Okay. We still can continue or not? Class still can follow or not? Last one, the last topic from chapter 2. Still can follow? The second method, how to define the transfer function. Still can follow or not?
Maybe.
Maybe.
Can.
Still can follow. Siapa ada dekat sini? Aina, Faika, Fatin, Hakim. Hakim mana? Tak dengar suara pun. Hakim, suara sikit Hakim?
Ya, madam.
Hakim. Hakim ada suara tak? Fatin ada. Hakim ada? Hakim, are you there? Sebab yang lelaki kita ada Mio, kita ada Hakim, kita ada Din kan? Yang saya ingat madam lah masa 2-3 kali kita masuk kelas tu. Hakim mana
Yes,
Hakim?
I'm here.
Din ada?
Ada.
Siapa yang tak ada? Akmal Kamal Kami dah lupa, tak ingat nama. Kejap Kita tengok siapa yang ada ni. Muhammad Kamal Ashraf. Tak ada kan? Mana Muhammad Kamal Ashraf? Muhammad Kamal Ashraf. Tak nampak pun ni. Nanti Megan buat absent lah ni. Tak nampak pun Muhammad Kamal Ashraf. Tak ada. Lepas tu Hakim ni ada ke tak ada ni? Megan nak dengar suara sikit Hakim. Are you there?
Andas kot. Ya.
Tadi ada tak? Tadi ada
Ada
ke?
tadi. Ada.
Ya. Maksudnya Muhammad Kamal Ashraf tak ada lah daripada awal Sebab madam tak check nama, tak tallykan nama ni kan. Okay, so kita ada berapa sebenarnya? Yang lelaki dalam tu 4 ya. Ada Mio, ada Hakim, ada Ashraf, ada Din. Okay, ada 4. Sebab rasanya Ashraf daripada kelas lain sebelum tu masuk kelas ni. Madam tak ingat sebab ada sebelum tu 3 orang kan. First kita punya meeting tu 3 orang rasanya lelaki kan. Lepas tu Ashraf
Ya,
masuk.
3. Lepas tu Kamal
3
masuk.
kan. Lepas tu Kamal join kan. Okay. So hari ni Kamal tak ada. Okay, tak apa. Kita teruskan kita punya sharing session. Okay, madam go through signal flow graph Signal flow graph means the second method we want to define the transfer function. Okay, so what is a signal flow graph ni? Signal flow graph is a diagram which represent a set of simultaneous equation. So meaning dekat signal flow graph ni tak ada block. Okay, maksudnya kita represent line and node instead of block diagram. Okay, instead of block diagram. Okay, let's say this one how to we want to draw block diagram into signal flow graph. So madam make it short form SFG, signal flow graph. Okay, so this is the alternative. We want to define the transfer function. Okay, instead of we have a block, we represent block into line. Okay, like this. Okay, we have a block. This is block G. Okay, and then represent into line, and then we label with G. This one. Okay, whatever the label inside the block, we label into the signal flow graph. Okay, and then the same goes to input, output, and also here. It's the same. You just redraw back. Okay, but the difference is instead of block, we have a line. Okay, and then we label the block, or we label the gain. Okay, G is our gain, right? Okay. Let's say, first example, what is this? Okay, the first, converting a block diagram to signal flow graph. Okay, what's meaning the red font 1, 2, 3, 4, 5 from the block diagram? Okay, let's say this is, we want to convert a block diagram into signal flow graph. The first step, okay, the first step, we have to label. Okay, label meaning, just now madam label pixel number 1, meaning this summing. Okay, this summing point I label with number 1. Okay, this takeoff I label with number 2. The next takeoff, sorry, pick off, label summing point and level takeoff point. Okay, so meaning the first one, okay, the first one is summing. I label with number 1. The second one is a takeoff point. I label with number 2. The third takeoff point I label with number 3. The next takeoff point I will label with number 4, and the last summing I label with number 5. Okay, now we finish label. And step number 2, we redraw the line. Okay, sorry, we draw knot and label and label. Okay, let's say first we try the we sketch the knot. Knot meanings. Okay, second step we sketch the knot, meaning knot. This is 1, 2, 3, 4, 5. Why 5? Because here we have 5, kan? 1, 2, 3, 4, 5. So we make it 5 knots here, and then we label back. Knot 1, knot 2, knot 3, knot 1, knot 2, knot 3, knot 4, knot 5. Okay. Now step 2 is done. Okay. After that, once you make it, you draw your knot and you label it, and after that you combine all the knots. Okay, you combine all the knots and you first label with the input here and label with the output here. Okay, class, still can follow until here?
Yes.
Yes,
Okay,
yes.
okay, very good. Ooh, sorry. Okay, first step we label. Label at the block diagram. Kita label dekat block. Diagram. Okay, so the second step, kita labelkan knot ni. Okay, lepas tu 3, kita buat line. Okay, and then number 4. Okay, number 4. Okay, number 4 nak buat apa? Number 4, kita start draw the line. Okay, just now. Okay, so we compare this one. Okay, so you can see from the signal flow. Okay, you see from here after we label. Okay, so let's say from knot 1 to knot 2. Okay, any item or any element from knot 1 and knot 2. Any block between 1 and 2. Any block between knot 1 and 2. Ada block tak? Any block between knot 1 and knot 2. Ada block ke tak ada?
Oh, tak ada.
Okay, if no block, you label with 1. Okay, we label with 1. Okay, if no block between knot 1 and knot 2, we label with 1. Okay, so how about between 2 and 3? How about between knot?
G1.
Okay, G1, right? So meaning between knot 2 and 3, we have G1. So you label G1 here. Okay, and central. So meaning between 3 and 4, we have G2. So we label G2 here. And then between 4 and 5, ada apa? Between 4 and 5 ada G3. So we label G3 here. Okay? Okay, how about this one? For G4. Oops, ya Allah. Sorry. How about G4? This one. Between knot, from which knot?
Between 2 and 5.
2 to 5.
Okay, good. Between 2 and 5. So we jump here like this. Okay. Between 2 and 5. Hold on. Okay. G4 is from knot 2 goes to 5. So meaning we make it like this, and you have to put arrow. Okay, you have to put arrow and label with G4. Okay, how about H1? How about this one?
1
Between
to
1
3.
and 3.
Okay, for H1, from knot 3 goes to knot 1, is it? Okay, from here goes to here. So, and then this is the arrow, and then H1. H1, this is, and you see the sign, minus. So we draw, and then we label minus H1. We label it minus, because minus H, okay, minus, we read from here, okay, class, minus, we bring back here, we get minus here, and then H, this is the H1, okay, this is H1 actually, betul tak? Ini H1, this is a H1, okay, minus H1. So how about another one? How about this one? How about the last one? Between 4 and 5. Oh, sorry. How about between 4 and 5?
H, but the H is 1.
Okay, between 4 and 5 here, okay, and then this is 1, right? Okay,
Yes.
okay, this is 1, so between 4 and 5, the arrow is like this. How we make it minus 1? Because this is a minus, so so you all have to write here minus 1. Similar, this is 1, and minus is from this sign, so you can get minus here. Okay, now you already convert block diagram into signal flow graph. Okay, everybody still can follow?
Yes.
Yes, madam.
Okay, similar with this example 2. Okay, so meanings, first you have to calculate the knots, right? This is a knot number 1, this is knot number 2, this is knot number 3, knot number 4, knot number 5, knot number 6. Is it correct? 1, 2, 3, 4, 5, 6. Okay, we have a 6. So meaning 1, 2, 3, 4, 5, 6. Okay. So we have to label number 1, number 2, number 3, number 4, number 5, number 6. Okay, class? Okay, from here, the second step, you have to make it the main line first. Okay. First label, knot, after that make it line, and then you have to put all the arrow. Okay, you have to put all the arrow here. Okay, and from there you have to put the arrow and then label. Between 1 and 2 you have G1. Between 2 and 3 you have G2. 3 and 4? How about 3 and 4? Okay, how about 3 and 4? Because 3 and 4 is a no block, right? So meaning this is, you make it 1. Okay? And then between 4 and 5, we have G3. Between 5 and 6, you have G4. Okay, class?
Okay.
Okay. How about H3? Macam mana dengan H3? H3 is between the node 1, node 2, node 3, node 4, node 5, node 6. Okay, H3 is from node 5 goes to node 2, right? Okay, this one 5 goes to 2. Okay, this is the arrow. And then H3 apa sign dia? Sign dia minus. So we got this one. Okay. Dan jangan lupa letak arrow dia. So you akan dapat minus H3 and you put arrow. Okay, how about H1? H1 here. H1 from where to where? From node 3.
3.
Yeah, from 3 goes to 1.
3
Kan?
to 1.
Yeah, 3 to 1 kan? Kita tengok dia punya arrow. Okay, so from 3 goes to 1 dan H1, lepas tu tengok minus. So you dapatlah ni, minus H1. Okay? So how about H2?
6 to 4.
Yes, very good. 6 to 4. Label dia H2, but this is a minus. So kita letaklah minus kat sini.
Minus.
Okay. This is the way how to convert a block into signal flow. Any question so far? So far so good?
Yes, madam.
Ayo, dah lari.
Good.
Okay, so far so good Okay. So this is the way we convert block diagram into signal flow graph. But how we want to define the transfer function? Macam mana nak check transfer function pula? How to define the transfer function? So we use Mason's rule. Define the transfer function. Meaning transfer function is a output labeled with C and input with S. Okay, this is how to define the transfer. Once you convert block diagram into signal flow graph, and then how to define the transfer function, we use Mason's rule to define the transfer function. Okay, can we make it until 2 o'clock, class? Boleh tak kita habis pukul 2?
Boleh.
Sure, boleh follow lagi sikit je lagi. Lepas ni boleh buat exercise dah. Yes. Okay. Boleh madam. Okay, very good Fahana. Hopefully boleh join ya siapa lagi, Syamili, Naima semua tu. Okay. So kita sambung sikit je lagi. Okay, now how to define transfer function using Mason's rule. Okay, this is also ada a few steps yang kita kena follow. Okay, first macam mana nak define from the signal flow. Okay, once you get the signal flow, we apply Mason's rule to define the transfer function. Okay, first step dia, ni buat apa? Sekejap. Okay, first, what is a Mason's rule? A technique for reducing signal flow graph to single transfer function that relate the output of system to its input. Okay, meaning dia nak define transfer function lah. Output over input. This is a transfer function. Okay. This one, number 1. Okay. We must understand some component before using Mason. Okay. First, kita kena define dulu what is a open loop. Hey, sorry. What is a loop gain? What is a forward gain? What is a non-touching? And what is a non-touching loop gain? So we have a 4 component you have to define before we use Mason's rule. Okay. What is a loop gain? What is a loop gain? This is the definition. The first one, forward parts. What is the forward parts? The product gain found by traversing a path from input node to the output nodes. Okay. 2 is a forward part, meaning the forward part, let's say we have input, example, okay. Okay, this is our input. And let's say this is our output. And this is the arrow. Okay, and then forward parts meaning the product gain found by traversing a parts from input node to the output node. Okay, this is your input node and then this is your output node. Okay, this is the forward parts. You follow this arrow. Okay, you start from input, you can go to output. You can follow the arrow. Okay, this is we mentioned forward parts. Okay, loop gain. What's the meaning loop gain? The product of branch gain found the traversing a path that start at the node. Okay, this is the keyword. Okay, this is the keyword. How to find loop gain. Start at a node and end at the same node without passing through any nodes more than one. Okay, and follow the direction, meaning follow the direction is you have to follow the arrow lah, okay, of the signal flow. That's how to make it loop gain. And non-touching, after that I will share you how the non-touching looks like. Meaning non-touching is a two loops are non-touching if they do not share a common node. Okay, so let's say madam show this example. Okay, this is the formula how to formula for Mason. Okay, this one. This is the formula. Mason's rule formula. Okay, meanings P. This one. Okay. What's a P? Just now P is a forward. K is a number of forward part, meaning we have one or two number of forward part. And then this is a determinant. Okay. And then this is the cofactor. Okay, from here, this one. Okay, delta K is a form by eliminating from determinant. Okay. Yeah. Okay, this is called determinant. Okay, this is called determinant, right? And then this one is called cofactor. Okay, this is called cofactor. Okay. So how to define the loop gain? Okay, let's say from this example, forward parts. Which one is a forward part? Just now, we say forward part is okay, class, can you give me what is a forward part? What's the element for forward part? We start from input, we can go to output node. Okay, let's say this is the input node. We want to go here, output node. Input, output. Which route you can follow? You start input, you want to go to output. Which track or which line you can to
G1,
follow?
G2, G3, G4,
Lagi 4, lagi
G5,
5,
G7, G8.
G7, G8. Okay, okay, very good. So how many forward part we have from this example? Okay, just now Mio say, let's say we make it P1. Okay, P represent for forward part, meaning forward part number 1. Okay, we label with the G1, multiply with G2, multiply with G3, multiply with G4, G5, multiply with G7, multiply with G8. Okay, 1, 2, 3, 4, 5, 6, 5, 7, 8. This is the root. This is the route from input goes to output. Okay, this one. Any forward parts? Ada lagi tak forward parts? Follow the arrow.
G5 replace with G6.
Okay, very good. So meaning forward part number 2, G1, G2, G3, G4, G6, G7, G8. Meanings is Allahu Akbar. Meaning we have another route. You want to go from input to output. Okay, we have another one route. Meaning we start from here, follow the arrow. Okay, we can go this way to go to the output. Just now, our first route from here to here. Okay, everybody, can you define the forward? How to define the forward? Everybody can follow?
Yes.
Okay, how about the rest? Suara Mio je ada ni, orang lain ada ke tak ada ni? How about others?
Yeah.
Yes, madam.
Okay, very good. So semua boleh follow How about Brian and the gang? Still can follow or not? Brian?
Yes. Yes, ma'am.
Yes. Hello, ma'am.
Okay, very good. Okay, this is the way how to define the forward parts. We have two forward parts. Is it we have some more forward part? Ada lagi tak forward part? Ada lagi forward? Ada ke tak ada? Ada.
Ada.
Ya.
P2 not include, 5 not include.
5.
G5. P2.
Dah?
G5.
Ada? Forward?
G4, P2 forward.
P forward. Maksudnya P1, mana P1? P1 kita yang hijau ni.
Okay.
Sekejap Madam
P2
pandangkan.
blue.
Okay, so P1 kita adalah yang ini. Kita bergerak pada sini, kita ikut dia punya arrow tu. Okay, daripada input kita jalan sampai sini. So itu adalah laluan P1 kita. So kita labelkan lah. Di 1, 2, 3, 4, 5, 7, 8. Betul tak? Ni kita punya P1. Kan? Semua ada kan? 1, 2, 3, 4, 5, 7, 8. Betul tak? Okay. So, untuk laluan P2, kita tengok arrow jalan mana kita boleh pergi lagi. So, kita follow kat sini. Kita boleh pergi naik kat atas. Lepas tu, pergi sini. That's why yang kita ada G6 pula tu, Din. Instead of G5, laluan lagi satu, kita ada G6. Okay tak? Okay, that's the way macam mana that's the way how to define the forward. Now, for this example, we have two forward parts, P1 and P2. Okay, how about the loops? How to define the loops? Macam mana nak cari loop pula? Okay, Madam pada Amir ni nak tunjuk loop. Macam mana nak define loop?
Yang ada feedback.
Ya, pandai pun yang ada feedback, yang ada arrow feedback tu kan? Okay, so the first one. Mana loop? Which one loop?
H1, G2.
H1, G2. Okay, meaning how to define the feedback? Meaning we start from here, we follow the arrow, and then you can come back to start node. Okay, betul tak? You follow the arrow ni. Okay, so meaning L1 equal to minus G2 H1. Okay, that's your loop number 1. Okay, some more loop. Mana
H2
lagi
and
loop?
G4.
G4 H2 negative.
Okay, G4. Okay, meaning you start from this node, you follow the arrow, and then you can come back to your start node. Okay, so meaning your L2 equal to minus G4 H2. Ada lagi tak?
G4 5
G5, H3.
H3.
Okay, so meaning yang ni kan, you start from here, you follow the arrow, and then you use this one to come back here. Okay, so meaning your L3 equal to G4. Alamak. G4, lepas apa? G5, lepas tu H3 kan? Minus. Is it? Okay, lagi.
Yes.
Ada lagi tak?
G4, G6,
Eh,
H3.
Okay, maksudnya lagi satu daripada sini, you pergi naik atas kan?
Yes.
And then you can come back. Betul tak?
Betul.
betul.
Okay, so meaning L4 equal to G4, G6, and then you come back using H3 minus kan?
Yes.
How about this one? Is it loop or not? This one?
Yes, loop G8 and H4.
Okay, very good. So meaning L5 equal to G8 and L4, H4. Okay, so we have 5 loops. Okay, untuk example ni, for this example, we have 5 loop. Okay, so just now, we talking about non-touching loop. Okay, we want to find out one non-touching loop. Okay, first step, kita dah define. First step, we already defined the forward parts. Okay, the second step, we already defined the loop gain. Okay, the third one, you have to define non-touching loop gain. Okay, what is a non-touching loop gain? Means you have to define the non-touching loop gain. Which one a non-touching loop gain? Which one non-touching each other? This is the L1. This is the L2. L3, the green color. And the blue color is the L4. And this is the L5. Which one non-touching loop gain?
L1 and L2.
Okay, lagi?
L1 and L3.
Okay. Lagi?
L1, L4, L1,
Okay.
L5.
Okay, very good. And then L5 also non-touching with the L2, L5 non-touching with L3 and L5 non-touching with L4. Betul tak?
Betul.
Okay. Okay. Okay, this one. Okay, you can see from here how to define the forward parts and how to define the loop gain. Okay, this is I show you the different figure, how to show how to define the loop gain from the complex signal flow graph. Okay, and then from here, the non-touching. Okay, like this, the non-touching loop gain. Okay, L1 non-touching with L2, L1 non-touching with L3 and accentra. Okay, right? This is the step 3. Okay, madam show already the step 3 is you have to define this one, non-touching loop gain. Okay, and after that, we have another rules. The non-touching loop gain, this is the product of loop gain from non-touching loop gain taken 2, taken 3, taken 4, and taken 5. Meanings, what I want to say. First, you have to define taken 2. Meanings taken 2, you compare 2 at one time. Okay, meaning first you have to compare first you have to compare L1 and L2, meaning taken 2, because when you show here non-touching loop gain, because non-touching loop gain, first you compare 2, 3 and etc. Okay, first you have to compare 2 loop at one time. Okay, at one time. Okay, first we compare L1 and L2. First you have to list down L1, L2, L3, L4, L5 because we have a 5 loops, right? Okay, first taken 2 meanings you compare 1 and 2. After that you compare 1 and 3. After that you compare 1 and 4. After that you compare 1 and 5. Okay, and then if non-touching you list down here. Okay, this is we list down here for non-touching loop gain, meaning 1 and 2 non-touching, you list 1 and 2. 1 and 3 also non-touching, you list down 1 and 4 non-touching, 1 and 2 non-touching, 2 and 5 also non-touching. We list here. Okay, we list, this is taken to at a time. Okay, this is taken to at a time. So, and then this is also 3 and 5. Okay, 3 and 5, 4 and 5. Okay, we have 7, is it? We have a 7, this one, 2 non-touching loop. Okay, we have a 7 item for taken 2, non-touching taken 2 at a time. Okay, is it we have non-touching loop taken 3 class? Ada tak yang tidak bersentuh 3 dalam satu masa? Ada tak? Non-touching taken 3 at a time. Ada ke tak ada taken 3?
Ada.
Ada? Sekejap Madam tengok komen. Ada tak yang taken 3? Dekat mana taken 3? Dia tidak bersentuh 3. Maksudnya jarak 3 tu jarak jauh. Dia tidak bersentuh antara satu sama lain. Ada ke? Taken 3 at a time. Which one taken 3 at a time?
L1, L2, L5.
L1, L2, L5, L1, L2, F5. Betul? Sekejap mana kita punya mana L1, L2? Dia dah jam. Sekejap ya. Alah, dia dah jam dah. Okay, kejap ya. Okay. Okay, kita ada, we have 3 non-touching loop gain. Okay, for taken 3 at a time, meaning 1, 2 and 5, 1, 3 and 5, 1, 4, 5. Okay, this one, this is a 3 non-touching, meaning how to show the 3 like this. Okay. Okay, meaning taken 3, taken 2 first we compare this one. Okay, let's say this is L1. This is the L2. Okay, the green one L3. The blue one L3. This is L4. And this is the L5. Okay, taken 2, we compare 2 at one time, meaning L1 and L2. This is non-touching, is it? This is your L1. This is your L2, meaning they're non-touching each other. And then like the L2 non-touching with L5. Okay. Now if taken 3, we compare 3 at a time, meaning L1 compare with L2, compare with L5. So meaning 3 loop is non-touching each other, right? So meaning you list L1 multiply with L2 multiply with L5. Okay, which one? The next one, L1 multiply with L3 multiply with L5. Lagi satu, L1,
L4, L5.
L4, L5. Okay, this is a second tree at a time. Okay? Second tree. Okay, taken 3 at a time. Okay. Is it have taken 4 at a time? Ada tak yang taken 4 yang tak bersentuh 4-4? Ada ke tak ada? Taken 4 at a time? Tak ada kan? Because so now we don't have any taken 4 touch each other at a time. Okay. So jadi okay, now kita dah habis kat sini. Okay, so let's say from here, supposedly you dah boleh define the transfer function. Okay. So ni nak cari apa ni? Okay, so madam leave it until here. So I think 2 o'clock already. So hopefully your homework, exercise 1, class, I want you try exercise number 1, exercise number 2. Madam kecilkan ni sikit. Okay, exercise number 1, exercise number 2. Okay, this is first you have to find out apa tadi? Cari apa? Satu, cari forward parts. Okay. And then 2, cari, you have to define loop gain. And number 3, non-touching loop gain. Okay, for exercise what? Exercise 1 and 2. Okay, for the next meeting, I will show you how to define the transfer function. How to use the Mason's rule to define the transfer function. Okay, using the 3 information here. Okay, that's your homework. How about exercise 3? Okay, exercise 3, you have to what? I give you block diagram. You have to draw the signal flow graph. Okay, from the signal flow graph, you have to define, okay, hold on. Okay, from here, okay, first you have to converting into signal flow graph. Okay, from the signal flow graph, you have to define the, just now, 3 item, forward parts, loop gain, and non-touching loop gain. This is your exercise. Exercise 1, exercise 2, and exercise 3. So how about, and also exercise number 4. Okay, similar with the exercise number 3. So step 1, you have to convert or you have to define the signal flow graph. Okay, from the signal flow graph, you have to define the forward parts. And apa lagi? And some more, loop gain and non-touching loop gain. Okay, let's do this exercise first, and after you familiar with the 3, with this step, so we can define using Mason rule. Okay, Mason's rule to define the transfer function. Okay, class. I think I want to stop here. Nanti lama sangat tak boleh masuk dah. Okay, betul tak?
Okay, madam.
Dah banyak sangat tak boleh follow. Okay. Okay. Ada soalan sampai sini? Any question?
No.
Tak ada, madam.
Okay.
No.
Kenapa tu? Okay, Bright.
Nói lớp học anh em ơi.
Okay, so can I stop here?
Yes.
Can I stop our meeting here? Okay, hold on. Okay, so